Hi guys, welcome back from all of our stow days. Sorry I couldn't be here today, but I do want to go over this worksheet with you guys just so that after all the time off, we can remember what we went over and how we can go back and classify these reactions, write everything out, predict the products, and balance. So I'm going to go over each of these questions with you in a different video. So we're going to start with number one. Number one gives us hydrogen plus oxygen. So if we look on here, we know that hydrogen is a single element. We know that oxygen is a single element. So the type of reaction that gives us the reactants of element plus element is a synthesis reaction, which can also be called combination. So a synthesis reaction, when you just have an element plus an element, is you're going to combine those to get a compound. So we want to start off by just writing out the reactants. So we have hydrogen and we have oxygen. Now, one thing that we always have to look for when we write out single elements is we need to ask ourselves, are these elements diatomic? Are they part of Hoberfinkel? So hydrogen and oxygen both are, they're the first two parts of Hoberfinkel. So those get a 2 because they're single elements. Now, when we write out our product, our compound, what we're doing with that is remember that when we write the compound, it's a combination of the two elements, but the subscripts don't get brought over. The way that we have to write this is we have to find their charges off of the periodic table. Remember, that's based on the column that they're in. So hydrogen is +1 and oxygen is -2. When we crisscross those charges, you're going to get your final compound as water, H2O. Notice how on here you have hydrogen has a 2 and oxygen has a 2 because they're diatomic. On the product side, though, because you crisscross the charges, the original subscripts from the reactant side don't matter. They don't follow over. The reason that it doesn't matter that those followed over or didn't is because we balance at the very end. So when we balance at the end, that's how we get these atoms to match on both sides. So for this first one, I'm going to use a rep chart just to show you guys how everything is written out. So remember, we put the elements in the middle. So we have hydrogen and oxygen. On the reactant side, we have 2 hydrogens and 2 oxygens. Remember, we're using subscripts to count. On the product side, we have 2 hydrogens and only 1 oxygen because of those subscripts. So the first thing that we notice that's off is our number of oxygens. So since we have 2 on the reactant side, we need 2 on the product side. To do that, we're going to go ahead and put a 2 in front of water. Now remember, that 2 distributes to everything. That 2 distributes to both the hydrogen and the oxygen. So on the product side, we now have 4 hydrogen and 2 oxygen. Now, we did fix our oxygen by doing that, but we messed up our hydrogen. So since we end with 4, we have to start with 4. Whatever number we put in front of H2, remember that it does get multiplied by the subscript. So we need something times 2 to give me a total of 4. So we're going to put a 2 there because 2 times 2 will give me 4 total. Our hydrogens match. We start with 4 and we end with 4. And our oxygens match. We start with 2 and we end with 2. All right, that'll be the very first problem. Good job.